Okay, so question 8 is looking at gradients of curves and sort of normals and equations of lines. If we have a look at the first part to begin with, so the question says that a curve has the equation y equals 2x squared, and we've got points A and B that lie on the curve, and they've got x coordinates 5 and 5 plus h. And we're asked to show that the gradient of AB is 20 plus 2h. It says the gradient, so instantly we should be thinking about the difference in y divided by the difference in x. I've got my x coordinates, but I haven't got any y coordinates at the moment, so I need to work out what they are by using the original equation. So when x is 5 for point A, then we can work out my y value by substituting in there. So we'd have y equals 2 times 5 squared, so y equals 50. And then for point B, we've got our x value is 5 plus h, so therefore our y value is going to be 2 lots of 5 plus h squared. If I ended up expanding out that bracket and simplifying, you end up with 2 lots of h squared plus 10h plus 25, which gives me 2h squared plus 20h plus 50. So I've got my 2x values, and now I've found out my 2 y values. Next step, like I said, is to do the difference in y divided by the difference in x. So the difference in y, I hope you can see that the b coordinate is further along the x-axis than the a coordinate, so I'm going to do the b coordinate take away the a coordinate to make it a little bit easier for myself. So we've got 5 plus h, and then take away 5, and the difference in, I've done that the wrong way around, difference in y first, apologies. So this one take away this one, so we have 2h squared plus 20h plus 50, and then take away 50, and that's all divided by difference in x, which is 5 plus h, take away 5, and then simplifying that, I get 2h squared plus 20h, and then the 50 and minus 50 cancel out, and then divided by just h. Then simplifying that a bit further, we end up with 2h plus 20, which is what I originally asked for in the question there. So then you're finished. That's your final answer for 4 marks on part 1 of that question. Part 2 goes on to ask you, how does your answer to part 1 relate to the gradient of the curve at A? We need to look at what would happen to the value of h if we put a and b closer and closer together. If we put a and b closer and closer together, it's going to tend to 0. So if I say that h is 0, so as h tends to 0, then the gradient is going to equal 20, because here, if I made h 0, we're just going to end up with 20. You could also think of it as, if I had my curve looking something like this, say this was point A and that was point B, if I had my straight line going across there, the gradient of that is 2h plus 20. If I reduced h, as in making the gap between A and B smaller, if I reduced it to 0 and came down here, you can see that the gradient is getting closer and closer to what the gradient of A would be. So by making h 0, making the difference between A and B nothing, we end up with just the gradient for A, at the point A. Okay, so question 3 is now asking us about the normal to the curve at A, and it meets the y-axis at C, and it wants us to find the y-coordinate. It just wants us to find the y-intercept of the normal at A. So we now know what the coordinates of A is from our first part, where we had x is 5 and y is 50. So we've got 5, 50. We also know what the gradient is at that point from part 2, where we said if h tends to 0, gradient is going to be 20. So we know that the gradient equals 20. We're asked about the normal to the curve, so we want the normal gradient. So that's going to be minus 1 over 20. And now I've got everything that I need to find out the equation of that straight line. I've got my gradient, and I've got an x and a y value, so I need to substitute that into y equals mx plus c. So y is 50, the gradient is minus 1/20th, x is 5, and then plus c is what we're trying to find out. And then going through to rearrange to find out what c is, so that 50 equals minus 1/4 plus c, so 50 and 1/4 equals c. Because we know that c is going to be the y-intercept of that graph, we can just say that the y-coordinate of c is going to be 50 and 1/4, and that can be your final answer for 4 marks for that whole of question 8.